This is a summary of my research, experiments, and education in 2022 within the Flight Robotics and Perception Group by Eric Price. In January, it was too wet and cold for flight experiments. So we upgraded our airship prototype with a new Windreiter inner hull with improved helium tightness. The weight savings allowed us to install both an onboard camera and a ballonette for pressure regulation in the field. During the first quarter, we conducted several successful flight experiments. This included the flight demonstration of Yutang Liu's reinforcement learning method for blimp control and my own perception-based nonlinear model predictive control airship formation path planner. The latter allows us to run AirCap on an airship with a fixed frame-mounted monocular onboard camera. That way, a stable formation of airships can visually track and follow a person or other mobile subject. In May 2022, we took a fleet of commercial multicopters to the Hortobágy National Park in Hungary. In cooperation with Hungarian biologists, we collected multi-view aerial footage of a herd of Przewalski horses for several hours each day for a whole week. This footage of natural behavior of groups of wild horses is highly valuable for our ongoing research and the research community as a whole. We also paid occasional visits to the Vehement Zoo in Stuttgart, where we collected footage of Gravis zebras in an enclosure, both with aerial and fixed ground-based cameras. This endeavor is now ongoing for the second year. In 2022, we offered 2 university courses. The Flight Robotics Seminar for bachelor students includes practical exercises in ROS and the construction of a fully functional multicopter. Our students gained practical robotic experience and experimented with control algorithms on real hardware. Our modifications this year include a switch to OpenPilot Revolution flight controllers. These allow testing of compiled control code in hardware in the loop simulation and eliminates the need to involve Simulink in real-time experiments. In Bayesian estimation for flight robotics, we teach master students the fundamentals of probabilistic filtering in aerial robotics, especially onboard state estimation with an extended Kalman filter, but also for aerial object tracking with simulated optical sensors. My own research this year focused on perception-based nonlinear formation control of airships. A preprint of my work, which was submitted to Robotic Automation Letters in September, can be found on arXiv. This includes open source code and a fully functional demo on GitHub. In order to exploit the data collected in Hungary, we improved an annotation tool to automatically detect and track horses and other objects in videos by combining SSD multibox for object detection with the RE3 tracker for temporal consistency. A human annotator validates the automatic annotation and, if needed, will make adjustments. But compared to fully manual annotation, this tool allows for orders of magnitude faster annotation. We retrained a variant of SSD multibox on our horse dataset to detect horses in real time with high precision. This horse detector was integrated into our newly built fleet of quadcopters, designed by our scientific assistant Benedikt Schwemmle. The new prototypes are very lightweight, stackable, and, under ideal conditions, can remain airborne for up to 30 minutes. They use an NVIDIA Jetson TX2 both for planning, communication, and neural network-based detection, and an OpenPilot Revolution flight controller, a camera, and a GPS receiver. So far, we built 3 out of 5 planned vehicles. In late November and December, we took this new fleet for a second 2-week trip to Hungary. We took more horse footage in winter conditions with mud and snow, and we also demonstrated autonomous tracking and following of wild horses with our new prototypes. These field tests, under hard and unforgiving real-world conditions in winter, helped us to validate our prototype designs and inform modifications needed for the fleet and future applications. This year concluded several important research chapters and will allow me to finalize my PhD thesis. There are also several upcoming research projects that allow us to use and further develop our technologies. You can find more information on our group and institute web pages, including links to our publications and source code. Thanks for watching.